Okay, so this is question 8a from the Euclid 2013. So the question is a cubed plus 2ab equals to 2013, and a and b are positive integers. So the first thing I noticed in this question is that I can factor out the a from the left side of the equation. So I can just change this to a times a squared plus 2b is equal to 2013. And now I just want to take this 2013 and do a prime factorization of it, and that's going to make the question a little bit easier. So I'm just going to rewrite my left-hand side. So I know that 2013 is not an even number, so the first prime I'm going to try to divide it by is 3. So 2013 divided by 3, that gives me 671. So I can write that as 671 times 3. Let's see if I can break down 671 even more. So I'm going to try to divide that by 3 again. It doesn't divide by 3. Let's see if I divide it by 7. Doesn't divide by 7. I'm going to try dividing by 11. And 671 divided by 11 is 61. So now I know I can write this as 3 times 11 times 61. And 61 is actually a prime number, so now we've reached the prime factorization of 2013. I'm just going to rewrite this left-hand side again. So we know that two numbers multiplied together are going to equal 2013. So I just want to split up 3 times 11 times 61 into two factors, and we're going to see how many ways we can do that. Also, notice that since both a and b are positive numbers, a squared plus 2b is going to be greater than a. So if we do 3 times 11 first, we can have 33 times 61. If we do 3 times 61, if we put those together, we get 183. So we can have 11 times 183. What if we do 11 times 61? Then we get 671 times 3. Okay, so those are all the different ways we can split up these three factors into two things multiplied together. And so we're always going to have the lower number on the left because a will always be smaller than a squared plus 2b if a and b are both positive integers. Okay, so for the first one, let's suppose that a equals 33, and let's solve for b. Okay, so we're basically trying to solve the equation. A squared plus 2b equals x, where x is going to be the higher number on the left-hand side. So for b, we can just write that as b equals x minus a squared over 2. And we're just going to plug in our values of a that we put in here, and our values of x is the higher number on the right-hand side. So using our first pair, we can say b equals x, which is 61, minus a squared is 33 squared, over 2, which equals 61 minus 33 squared equals divided by 2. Okay, so we got a negative number there. We got negative 514. So this is not a possible solution to the equation because a and b must both be positive. Using the next pair of numbers, b equals 183 minus 11 squared over 2. So let's put that into the calculator. 183 minus 11 squared equals 62 divided by 2. And we get 31. And for the last one, b equals 671 minus 3 squared divided by 2, and that equals 671 minus 3 squared over, no, sorry, that's wrong, minus 3 squared equals divided by 2, and we get 331. Okay, so our solutions are just the ones where b is positive. So this and this. So the solutions to this equation is, or I should say are actually, 11, 31, and 3, 331. And if you put that back into the calculator, into this equation over here, you will see that it is the correct answer.